Hello everybody. In this video we're going to discuss the ideas of marginal revenue and marginal cost. And these concepts are really important when we're trying to determine how much of a good or product a company wants to produce. We have this equation down here, MR equals MC. The MR stands for marginal revenue and the MC stands for marginal cost. This is a really important equation that's used over and over again repeatedly in microeconomics. Marginal revenue is just how much extra revenue we have coming into our company if we produce one additional unit of our good. Marginal cost, likewise, is if we produce one extra unit of the good, how much more expense accrues to our company? What's the extra cost of producing that extra unit of good? So the reason we're interested in this particular equation is if the marginal cost exceeds marginal revenue, if it costs more to produce an extra good than what we get in revenue when we sell it, well, that's a bad decision in general for a company. We don't want to produce something if it costs more to make than what we could sell it for. So that's the whole idea behind this equation. So what we're going to do today is look through some charts and graphs kind of detailing this idea, and by the end of this lecture you should be able to use this information to figure out how much a particular company would produce given the revenue and cost associated with its production levels. So we're going to look at this chart here for a company that is actually producing wheat. So we can see over here in this first column, these are bushels per day, how much wheat this company produces. And let's go through and look at a situation where it's producing 0 bushels at all. So it's not producing anything whatsoever. Well, in that case, marginal revenue is 0. The reason is, if we're not producing anything, no revenue is coming into the company. Our total revenue, you can see here in column 3, is just our quantity produced times the price. Alright, well, we haven't produced anything, so that's 0, so no money's coming in, no marginal revenue, no total revenue either. But it's interesting to see we have a total cost of $15 here. So if we're not producing anything and we still have a total cost, that means it has to be a fixed cost. And remember the difference between fixed cost and variable cost. Fixed costs don't change. Regardless of how much we produce, we always have those costs. So for instance, maybe this company that produces wheat has to pay for renting a tractor, and maybe it pays $15 to rent a tractor. That's a really low amount, but we'll just use that for this example. So whether they go out and they produce 0 bushels in a day or 16 bushels in a day, they still have to pay for the money for renting that tractor. Maybe they're under contract for it. Well, that's considered a fixed cost. A variable cost is something that varies with the level of production. So maybe we have workers out there in the field. If we have more workers out there harvesting the wheat, well, we're paying more of a salary, more production is going on, more cost. That's variable. It varies with the level of production. So in this first case, if nothing's being produced, and we have a total cost, that has to relate to some type of fixed cost out there. We can see here there's no marginal cost. The reason is, remember, marginal cost is how much additional cost we have with the production of one additional unit. Well, no units produced, so no marginal cost. Likewise, no average total cost, yet average total cost is just our total cost divided by the quantity produced. Well, we haven't produced anything yet, so we can't have a figure in that column. And number 7, column number 7 over here, this is looking at our economic profit or loss. And that's just our total revenue minus total cost. So for this particular company, if we haven't produced anything, well, we don't have any revenue coming in because we don't have anything to sell, but we have $15 in costs. So if we take that 0 minus 15, we're actually losing money at this point. We're $15 in the hole. So it actually makes a little more sense if we look at a level where we're actually producing something. So let's look at the statistics when we produce 1 bushel of wheat. We can see here our marginal revenue in that case is $5. So that means we're able to sell that 1 bushel on the market for $5. And you can see our marginal revenue, regardless of how many units we're producing, is always $5. That means we're operating under perfect competition. The reason we know that is because it's equal all across the board, regardless of the level of production. And that occurs because if we're in perfect competition, our production doesn't influence the price in the market. Under perfect competition, there's many sellers out there in the market. So regardless of whether we sell 0 bushels a day or 16 a day, we're only getting $5 per bushel. Now, if we look at other types of economic organization, like oligopoly or monopoly, which we'll talk about in the future, those companies' production levels actually affect the price in the market. But under perfect competition, we're going to have constant marginal revenue. In this case here, $5 is coming in for each bushel we sell, regardless of the amount of bushels that we produce. So if we look at our total revenue, well, again, that's just our quantity times the price. We're producing 1 bushel in this case. We're getting $5 for it. All right, total revenue coming into our company is $5. We see here our total cost is $19.75. So when we went from producing 0 to 1 units, our total cost went from 15 to $19.75. That marginal cost is the change in total cost divided by the change in quantity. So basically that's looking at how much did our costs change if we produced 1 more unit. Well, we did have $15 in cost. Now we have $19.75. We can see we added $4.75 in cost when we produced that 1 extra unit, when we went from producing 0 to 1. So that's the whole idea of marginal cost. How much do our costs increase when we produce 1 extra unit? We can see our average total cost in this case is $19.75. That's just our total cost, $19.75 divided by quantity. All right, it's only divided by 1 in this case. So average total cost in that case, $19.75, and we're actually still losing money here. We sold a bushel now, so made $5. We got $5 coming into our company, but we have $19.75 in cost. Our costs exceed our revenue, so we're still losing money here. We're losing $14.75. So the rest of this chart kind of goes the same way. What I really want to point out here is to figure out how much we should produce. And we want to produce until the marginal cost equals the marginal revenue. Remember our equation we looked at back here, that MR equals MC. We want to produce up until the point where we're equal there. Once marginal cost exceeds marginal revenue, we want to stop producing. We're losing money at that point. So for this company here, we want to stop producing at 12 units. So let's go through that particular line item and look what's happening. When we're producing 12 units, we're getting $5 for each bushel we produce. $5 times 12 is 60. We have $60 in revenue coming into our company when we sell those 12 bushels for $5 each. Our total cost is $48. This information here is given. We're not calculating column number 4, so we're given that information in the problem. Marginal cost, we can see, is how much our cost increases when we go from 11 to 12 units. Well, when we go from $43.25 in cost to 48, our cost is going up $4.75. So that's the marginal cost in that case. Average total cost is just our total cost, 48 divided by 12. That's $4. We have an economic profit in this case of $12. The reason we have a $12 profit is, well, we sold the bushels for $60 at that production level. It costs $48 to produce them. We have a $12 profit. So that marginal cost in this case, we could see, is greater than, or actually is less than our marginal revenue. Marginal revenue, $5, is greater than marginal cost. We see here if we produce 13 units, notice we're getting $5 in revenue if we produce 13 units, but it costs us $6.50 to produce that 13th unit. When we're producing 12 units, we had $48 in cost. It goes up to $54.50 when we produce that 13th unit. So it's costing us $6.50 to produce that 13th bushel. Well, if it costs us $6.50 to make that extra bushel, and we're only selling it for $5, we're actually losing money by producing that extra bushel. And we can see that here, our economic profit's actually less when we produce 13 units. We're making $10.50 in profit when we produce 13. We're making $12 in profit when we produce 12. So it's better for us to produce 12 units than 13. We want to stop at that point. And that's that whole idea of producing up until the point where our marginal cost equal marginal revenue. At 12 units, we have marginal revenue of $5. Marginal cost was less than $5. It made sense to produce at that point. At the 13th unit, that marginal cost of $6.50 exceeds the marginal revenue of $5. So we wanted to stop before that point. We're losing money by producing more there. We can see, again, we could look at this column as well. $12 is the highest figure on this list for a profit. So we can kind of do it in that way as well. We can look and see what's our highest profit level. If we produce 6 units, for instance, well, we're still losing money there. We're losing $2.50. If we produce 14 units, well, if we run the numbers there, we're making $6. That's good. We're making a profit, but not as good as if we stopped at 12 units.